So this is a brief run through of the specification points on 21st Century Science C1, which will be coming up in your June exams. So all I've done here is I've taken the specification document, which includes all of the statements of the chemistry you need to understand for this topic, and anything that needs a bit of elaboration I'm just going to run through a little bit. So first one first. So you need to recall, so you just need to know that the atmosphere or the air surrounds the Earth and is mainly made up of these three chemicals: nitrogen, oxygen, argon, and there's small amounts of water vapor, carbon dioxide, and other gases. So water vapor obviously is in the form of H2O, and as it's a vapor it means it's gaseous, so we put a little G after it. Carbon dioxide is a gas as well, and this is in very small amounts, about 0.04%, but vital for the photosynthesis in plants. And then there are a bunch of other gases, including things like helium and methane from other sources, but these are the main ones. Recall that the air is a mixture of different gases, consists of small molecules with large spaces between them, so this just takes us back to your Key Stage 3 science, when we consider a solid, the model of a solid, with all the particles neatly packed together, all touching. So that would be a solid. With the liquid, we've got the particles still touching, but in a more random arrangement, not so ordered. So that would be your liquid. And gas, we show the particles well separated and not touching, and then moving fast. So that's all that is asking you to remember. So it's consistent of small molecules. So molecules, we've got at least two particles joined together. Sometimes they're different, sometimes they're the same. So this would be a molecule of an element, for example oxygen. This would be something like nitrogen monoxide, where they have different elements joined together. But this would be a molecule. And this would be an individual atom because it's on its own. So that's an atom. And these ones are examples of molecules. So the percentages you need to know as well. So any time it says recall on here, you need to know these things. So 78% nitrogen, 21% oxygen, and 1% argon. These are the main ones. Understand that other gases and particulates may be released into the atmosphere by human activity or natural processes, and these can affect air quality. So human activities, mainly this is burning of fossil fuels. And our fossil fuels are coal, oil, and natural gas. And when we burn these ones, we generally release carbon dioxide, and carbon dioxide is a greenhouse gas. And too much greenhouse gas in the atmosphere leads to global warming. So that's the main one it's talking about there. Natural processes, e.g. volcanoes, the main one that they're talking about there in volcanic activity is, again, as it says here, in terms of the early atmosphere, but it also happens now, it can release carbon dioxide, and carbon dioxide again is a greenhouse gas, and that leads to global warming. The other main gas which is given out is SO2, or sulfur dioxide, and when that interacts with oxygen in the air and water in the atmosphere, that can lead to acid rain. Okay, so volcanic activity can release sulfur dioxide, and burning of fossil fuels can also lead to the release of sulfur dioxide. The Earth's early atmosphere was formed from volcanic activity consisting mainly of carbon dioxide and water vapor. So when the volcanoes in the early atmosphere, the early Earth's past, it released the carbon dioxide from the carbonate rocks and the water, which was buried underground, that went up into the atmosphere, and eventually, as it says here, the water vapor condensed to form the oceans. So in that case, when we've got the early Earth's atmosphere, so this Earth was formed about 4.5 billion years ago, and that's today. So the atmosphere here was mainly CO2 and H2O and some other gases, and today it's mainly nitrogen and oxygen. So obviously we had other gases in the atmosphere. Ammonia would be the other main one, and that nitrogen here ends up in the nitrogen there. Here the atmosphere, or the whole planet, was very hot. Here it's comparatively cool. When it's hot, H2O is a gas, and so it's up in the atmosphere in clouds. And here H2O is a liquid, so it now exists as the oceans. Okay, so in the early Earth, very hot, water is a gas, so it's up in the clouds. Now it's much cooler today, so it's a liquid, and it exists as the oceans. Explain how evolution of photosynthesizing organisms added oxygen to and removed carbon dioxide from the atmosphere. So you'll know this from your biology, but if you take carbon dioxide and water, and you have photosynthesis going in plants, so you need some sunlight as well. For that to happen, you end up with glucose and oxygen. Okay, so this is the food for the plants, so they store that and use it to build their cell structures and proteins and fats and all those kind of things, and oxygen in this case is a waste product by those photosynthesizing plants. The most important thing is the carbon dioxide is being removed from the atmosphere, and it's being locked up in plants here. Explain how carbon dioxide was removed from the atmosphere by dissolving the oceans and then forming sedimentary rocks and by formation of fossil fuels. Well, this glucose, which leads to plants being growing, when they die, so death and decay and burying, that leads to plant material, or dead plant material, underground, and then if you treat that with heat and pressure and time, eventually they turn into fossil fuels. Okay, obviously this takes heat, so that's it being pushed down, the pressure caused by multiple layers of sedimentation on top of it, and millions of years for this to happen. We end up with fossil fuels, but importantly the carbon dioxide that was in the atmosphere ends up in the plants, ends up in glucose as food. This ends up in plants. When they die, they're buried and they end up turned into fossil fuels. The other way that it's talking about the carbon dioxide being removed from the atmosphere is if we've got carbon dioxide as a gas, if that dissolves into the oceans, then it's within the oceans, and then that can be absorbed into the bones and shells of sea creatures. As carbonates. So calcium carbonate is the normal one. Okay, if they die, they sediment to the bottom, to the ocean floor, and that eventually forms sedimentary rocks, e.g. chalk. Okay, so anytime you see chalk, all that is the bones and shells of sea creatures from millions of years ago. Understand how human activity has changed composition of the atmosphere by adding small amounts of carbon monoxide, nitrogen oxides and sulfur dioxide to the atmosphere, and extra CO2 and small particulates to the atmosphere. So again, this is generally from burning of fossil fuels. So the carbon monoxide, if we take the fossil fuels, so let's take methane as an example, and if we burn it in plenty of oxygen, lots of oxygen, then we end up with carbon dioxide and water. If we have limited oxygen, then we can end up with carbon monoxide or carbon soot particles. Carbon monoxide is poisonous to humans, and this carbon particles can get into our lungs and lead to respiratory problems. Okay, so this is incomplete combustion. That'll lead to these problems here. The nitrogen oxides and the sulfur dioxides, we've already discussed these from volcanoes, but these are particularly under human activity. These generally occur when the sulfur dioxide is if you've got sulfur contamination in fuels, then you end up with sulfur reacting with oxygen to form sulfur dioxide, and as said previously, oxygen then in the atmosphere and water. That can lead to acid rain, and acid rain destroys plants, buildings. The nitrogen oxides, this generally happens in cars, in internal combustion engines. So if you've got high temperatures and pressures, in internal combustion engines, then the nitrogen and oxygen from the air, not the fuel, and that's a common mistake in exams, so remember that one, react to form nitrogen oxides. Okay, and these are similar to the sulfur dioxides. These can lead to acid rain, and they also can cause big problems with respiratory conditions as well. They aren't very good for the lungs. Extra carbon dioxide, as I've discussed, that's burning of the fossil fuels and small particulates. Again, that's from the previous page. Understand that some of these substances are called pollutants, and they're directly harmful to human health. So this is when it says particularly, gives particular examples in the specification. It's always good to learn these ones. So carbon monoxide reduces the amount of oxygen blood can carry. In particular, it binds to the hemoglobin and stops it carrying oxygen. Some are harmful to the environment and so can harm humans indirectly. So sulfur dioxide causes acid rain. So they are two good examples to learn. So you've got those in your mind when it comes up. Okay, so that's the first part of C1. I'll put the second part of C1 in a separate video.